So let's take a closer look at some particular polygons. We're going to start with our parallelogram. So we want to know what makes a parallelogram, and that's what this whole section is talking about, right? What are all the properties of a parallelogram? So let's first start off with the definition of a parallelogram, and hopefully you remember this from before, or you can kind of guess, but look at the name. You see parallel in there. So a parallelogram is a quadrilateral, meaning it has four sides, with two pairs of parallel sides. All right, so let's call this quadrilateral ABCD. And this definition, right, this is my definition of parallelogram. What it says is that if I know your two pairs of sides are parallel, so for example, AB is parallel to that opposite side CD, right, and BC is parallel to AD, then we can conclude that ABCD is a parallelogram. And you can use the symbol for parallelogram. And remember, because this is a definition is a biconditional, meaning it goes both ways. So if I told you you have a parallelogram, then the one thing you can conclude is that the two pairs of opposite sides are parallel. And then you can go from there and use like same side interior angles and whatever with the parallel meaning. But that's, again, what you know by definition, okay? Now, we also have some theorems that'll also help us understand parallelograms. So, basically, I've given you a sentence starter. So, if we know a quadrilateral is a parallelogram, so, right, if a quadrilateral is a parallelogram, then certain things will be true. And the first one says that its opposite sides are congruent. All right, and going back to that parallelogram we drew earlier, that ABCD, if we know it's a parallelogram, meaning we know the opposite sides are parallel, then we can say that the opposite sides are congruent. So remember, which sides are the opposite sides? Well, that would be like AB and CD, right? BC and AD. So again, think about what this means, right? So if we are given ABCD is a parallelogram, and again, that's a symbol for parallelogram, then we can say that AB is not only parallel to CD, but it's also congruent to CD, right? And also, BC is congruent to its opposite side. All right, so that's the first of our theorems. The second theorem says that the opposite angles are congruent. So once again, we had to be given a parallelogram, so let's go back to that ABCD. Right? And then what we can say now is the opposite angles are congruent. Remember, opposite angles are angles directly like across from each other, meaning they're like across that space from each other. So for example, angle B is congruent to angle D, right? And also angle A. Let me make that a little bit clearer. So angle A is congruent to its opposite angle, angle C. Right, so they're not connected on the same edge. So that's the second theorem. Remember, these are all assuming we know we have a parallelogram first. All right, next up, we know that if we have a parallelogram, then its consecutive angles are supplementary. Remember, consecutive means one after the other. So, all right, so once again, starting off with our knowledge that ABCD is a parallelogram. And this time we're saying the consecutive angles, remember again, that means one after the other. So that would mean things like angle A and angle B are supplementary, right? But not only that, but you have four pairs of consecutive angles, right? So we also know what other angles would be supplementary. Well, we would know that angle B and angle C, right? Because they're also consecutive. What else? Well, we'd also know that angle C and angle D are supplementary. And finally, angle A and angle D. So again, consecutive, which is different from opposite. All right. We've got one more property or theorem. Basically, again, once we know we have a parallelogram, these are things we can say about it. So the last one says that its diagonals bisect each other. And remember what diagonals are, right? When you draw diagonals or rectangle or whatever, they connect your opposite angles. So for example, right up here from B to D, this is a diagonal, right? And from A to C, that's another diagonal. So this theorem says basically the diagonals will bisect each other, meaning they cut each other in half. So that means from A to this intersection I'm going to call M, that AM is congruent to CM, right? BM is congruent to DM. However, notice the chunks aren't all congruent to each other, right? One diagonal is one piece of information, the other diagonal is the other. So don't say BM is congruent to AM. We don't know that. All right, so that's important. Okay, so let's go ahead and write this down. Okay, so those are the 5 things we know about parallelograms. So remember, don't just look at the theorems, but also include the definition, right? We know opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So let's use this now in some examples. So example 1, in parallelogram, remember that little symbol right here means parallelogram. Parallelogram CDEF. DE is 74, DG is 31, and the measure of angle FCD is 42. Okay, so in this case, I usually find it pretty helpful to draw a diagram, right? Remember, how would you draw a diagram given this information? Well, first, draw yourself a parallelogram, right? Oops. Let me make that a little bit nicer. So, again, you want to draw yourself a nice parallelogram. And then look at the way it's named, right? C, D, E, F. So pick a vertex to start with and say that's C, then go around in a circle. D, E, F. And that'll give you the image of the problem, okay? And then you can go ahead and label what we know. We know DE is 74 millimeters, and that's a side, not an angle. Oops, 74, not 77. Remember, never put sides and angles together, all right? We know that DG is 31, and something I forgot to write down here, G is going to be, oops, this point right here where the 2 diagonals meet. Sorry about that. Okay, so we know DG is 31, so let me go ahead and write that in. Okay, and then we know the angle FCD is 42. And remember, when we're talking about angles, we want to start at F, right? Go to C, and then turn around for D. And that whole pink thing, that's the entire angle. That is 42 degrees. All right, so let's use that information to answer A, B, and C. Okay, so let's think about CF and its relation to other sides. Remember, CF, this is a side. Please, please don't tell me CF is 42 degrees. Remember, degrees are angles, sides are like meters, millimeters, inches, etc. And I realized I forgot the other M here. Okay, so CF, what is it related to? Well, we know opposite sides are congruent, right? So what should CF be congruent to? Hopefully you're seeing CF should be congruent to DE. So that means if DE is 74, CF is 74. All right, so that's what we wanted to pull out here. Okay, what about the next one? The measure of angle EFC. Well, remember, trace it out. Where is angle EFC? Start at E, go toward F, and make that circle round towards C. Well, that's that red angle down here. So that's what we're looking for, right? Well, how does that relate to that 42? Because 42 is the only angle I'm given. Well, what do you know about angles EFC and angle FCD? Well, they are same side interior, or consecutive, right? Which makes them supplementary. So that means 42 plus whatever the measure of angle EFC is, that should all add up to 180, right? So that makes my work pretty simple. Just subtract to get 138 degrees. All right. And then finally, we want to figure out DF. Well, if you think about DG, because DF is a diagonal. So let me back up for a moment, right? So DF is a diagonal. And there's only one thing I know about diagonals in parallelogram. What do diagonals do? Well, diagonals bisect each other. Which means CE does what to that whole thing DF? Well, CE should cut DF in half, right? So that means this 31 DG is the same thing right over here, right, for GF. So DF should equal 31 plus 31 to get 62 millimeters. Okay. Let's take a look at the next example. Right? Again, I'm giving you a parallelogram, so that's awesome. I'm telling you that in the problem. So now we can use those 5 properties, right? Opposite sides are parallel, congruent, opposite angles are congruent, etc., etc., etc. Okay? So let's figure out how to find YZ. And again, YZ is a side, right? Not an angle. So sides mean, what letters are we looking at, or what variables are we looking at, A or B? We should be looking at A. So please, please, please do not try to throw in the B here, okay? So let's look at the 6A plus 10 and the 8A minus 4. Well, YZ is 8A minus 4. Now, how does that relate to the 6A plus 10? Well, we know YZ is congruent to its opposite side, WX, right? So that means 8A minus 4 is equal to 6A plus 10, right? And then just go through and solve just like you do in algebra. Don't stop here because I'm looking for YZ. So plug it back in. So that's going to get me 52. Okay? Next up, measure of angle Z. So now we're looking at angles, right? This is an angle, which means which variable are we looking at? Clearly the B's, right? So how does angle Z relate to angle W, the 2 angles in my problem? Well, we should know that angle Z and angle W are supplementary because they are our consecutive angles, or same side interior angles, in our parallelogram. So that means 9B plus 2 is plus 18B minus 11 should all add up to 180 degrees, right? And then just do your algebra here, and we should get all that work to give us B is equal to 7. And then again, is that my answer? No, I need to find Z. So the measure of angle Z is equal to 9 times 7 plus 2. So that's going to give me 65 degrees. And now I'm done. All right. So be careful. Again, I'm seeing this in your tests and quizzes. Not everyone does it, but it happens often enough that I've noticed. Don't equate angles and sides, right? Don't put them together. Angles are angles, sides are sides. Diagonals are diagonals, sides are sides, angles are angles, right? Do not mix up degrees, millimeters, miles, etc. All right? Sides will never add up to 180, okay? Only angles add up to 180 in triangles, etc. Okay? Let's do one more example and we'll do the proof together in class. So, example 3, we've got 3 vertices of our parallelogram and we need to find the last one. So here, personally, easiest thing to do for me is to graph it. So let's plot our points. All right, so those are the 3 points that I have, J, K, and L. And remember, look at the name here, and this will tell you which order to connect the dots. So I should connect J to K, K to L, and then L to some phantom M. And remember, we need to find that point. So how do I do that? Well, opposite sides should be what? Well, they should be parallel and they should be congruent. And what's one quick and easy way to get an opposite side that's both parallel and congruent? Use your slope, right? Count your rise over run. So I know J to M should be the same slope as K to L. So I can just count that rise and that run. So this is up 1, 2, 3, 4. And this is over 1, 2, 3, 4. So let's repeat the exact same thing. Go up 4 and over 4. So that's going to get me this point 7, negative. All right, so our point M is at, again, 7, negative 4. And you can always check this by, just checking that last, the other side, for example. So from J to K, it's up 8, 10, and then to the left, 6. So I can just make sure this is up 10, and then left, left 5, right? And that looks good. Okay, so that's my answer. We're going to do the proof in class, so come back with questions, and see you guys later.